In today's episode, we're just going to discuss about the workflow of Python. Whatever the programming language you study, especially for data analytics, you need to know how your data is getting processed. For any tool or any application you develop, you have to understand the process flow. Similarly, if you're working on Python, you need to know how Python differs from other programming languages. And as a fresher, if you go for any interview, you can expect some questions from the workflow of Python. So let's dive into the Jupyter notebook and understand the workflow scenario. Python workflow. Now, normally, as I've already mentioned in my previous video, we need to process the source code into the machine understandable language. Hence, we make use of high-level programming languages like Python or Java, whatever it is. So Python is a interpreter and a compiler oriented programming languages. Some programming languages, they work only on compiler, but Python, it makes use of an interpreter which inside it actually has the compiler. So I have already mentioned in my previous video, interpreter, compiler, they are like a software. They have some components which conduct this workflow. Similarly, in Python interpreter, it has several components. So they are Lexer, which actually perform lexing, parser that perform parsing, compiler that performs compiling, and it has a Python virtual machine, which in short called by the name PVM. The abbreviation is PVM. So normally we are writing a sample code, say a is equal to 5, b is equal to 5 and c is equal to a plus b. So actually inside this, we need this Python interpreter. It processes the given data and gives the output that c is equal to 1010, which is nothing but 10. I have just written the binary value of 10. The real output will be 10 will be displayed when you calculate a and b. So let me zoom this. So normally we are writing the source code. So in the interpreter, Python interpreter, first it enters the given source code. It actually has the extension .py, whatever ABC is. Like for an example, you can give any name like a country.py, calc.py, any program, any file name that you are writing a program, you're giving a file name, right? So that file name is nothing but abc.py. Py is the extension for Python. So once I have written the source code, when I start executing it, we need to know these 4 stages. By crossing these 4 stages only, the Python produces the output. So initial stage is a Lexing, which is nothing but a tokenizing. What this tokenizing is all about? Tokenizing is nothing but making the entire source program into a number of tokens. Actually, it divides each line. As we know, Python is an interpreted oriented language. It interprets line by line. So this tokenizing will make these statements to execute line by line. So I'm getting here, as I've shown here the example, a is equal to 5, b is equal to 5, c is equal to a plus b. So line by line it gets actually splitted. Next stage is the parsing. So this output is given to the parser, which depicts abstract syntax tree. This abstract syntax tree is actually a huge concept. So what it is, the real logic behind this abstract syntax tree is, it depicts the relationship between the given data. So if you want to know much about this abstract syntax tree, once you become familiar with programming languages, you can search in Google, you can study various blogs in order to know about it. Putting simple, a parser will perform the scenario in order to establish the relationship between the tokens. After this parser, we have a compiler. So what this compiler actually do? What this compiler actually does is, it is the high-level source code will be converted into a machine understandable code. Machine actually understands binary zeros and ones. So this compiler will make use of that, will actually perform that particular task. So A5 whose binary value is 0101 and B whose binary value is 0101. So we'll make the output, it does the calculation. So a compiler, it acts as a bridge actually in order to make the machine understand your source code in its own language, and also it generates a .pyc file. So this .py once it crosses the compiler, it generates the intermediate bytecode. This intermediate bytecode is nothing but .pyc file. So it does some activities and it generates it in a form of .pyc. Now this compiler generated intermediate bytecode, and if you're not sure about the meaning of compiler, interpreter, bytecode, object code, please do watch the link in the above. It will pop up so that you can understand all these relationships. Okay, so the output of this compiler generated .pyc file is given to the Python virtual machine. So why this Python virtual machine? Yes, that is the most salient feature of this Python interpreter. So all these are available inside the Python interpreter. So what it actually does is like, it, as we know, Python is an platform independent programming language. Whatever the platform it is, it executes the result as that particular architecture, that particular machine architecture understands it. Similarly, this Python virtual machine will convert the compiler generated intermediate byte code into a machine executable byte code, machine code. So compiler is converting that high level programming language into a machine understandable format, whereas this Python virtual machine will convert the compiler generated .pyc file into a machine executable machine code. And finally, the output of the Python virtual machine, or the entire output of the Python interpreter, will be given as the proper output. So this is how the Python architecture actually works. So putting simple, a Python architecture, the Python interpreter has 4 major components. Actually, Python interpreter is again a software. So it has 4 major components. One is a lexer, next one is a parser, third one is a compiler, and fourth one is a Python virtual machine. So lexer actually performs the tokenization operation, thereby it divides a line into different number of tokens, which in turn pass to the parser. It depicts the relationship between these data by the concept of abstract syntax tree. The output of the parser is given to the compiler, which in turn converts the high-level programming language into a machine-readable format, thereby it do the calculation, and the output of the compiler will be a .pyc file, which in turn given to the Python virtual machine, which deliver the machine intermediate bytecode into a machine executable code such that we get the output. So this is how the Python interpreter actually works. So please be clear with these terms in order to understand the workflow of a Python. So the Lexing concept, the tokenizer, is a very important feature. That is the major reason for an interpreter. Like, it executes a line by line. So each and every line, the source code is divided into each different lines. So line by line, the actual execution happens. That is why we call Python as a interpreted language. For an example, I will show you an example. Let me write a code here. Say A is equal to 10. B is equal to 20. Now C is equal to, I am going to give one string value I. So now I will be calculating A plus B. So when you add 2 integers, 2 numbers, you get a number as an output. You cannot add a number and a different data type or a string or any 2 different data types cannot be added. We do different operations for that. So 2 similar data type, say an integer, can be added. But when I try to, let me make this as a print statement, print A plus B. So automatically we should get the output 30. But what happens when we print the variable C with A? So if this is going to be a normal programming language like C, C++, Java, this particular, let me zoom it, this particular statement is an error. So because of this error, when the complete source code is compiled, it throws an error since it has one particular error. But in Python, all the codes will be divided into each and every segments, different tokens. So each and every line gets executed line by line. So only when there is a particular error, it actually stops by that particular area. It does not stop the entire program. That is one of the salient feature of this Python. So when I run this program, you can see anything wrong, by there my program gets stopped. So if you have any error, or if you made any wrong calculations in your code and it is available in the end of your program, fine, all the correct code will be executed, and when my interpreter tries to execute that particular wrong code, you will be caught out. But if you have that error code in the very starting of your program itself, then the entire correct scenarios will not be executed, because it is actually getting stopped in that particular error code itself. So this is how the Python interpreter actually works. I hope you will be clear with the session. So let's meet you in the next episode with an interesting concept. Bye.